When it comes to culinary delights, there's a quality that often takes center stage: crispness. Whether it's the crackling crust of freshly baked bread or the satisfying snap of a potato chip, crispness plays a vital role in the enjoyment of food. Crispness in foods is a sensory attribute that can be measured using various methods. A few commonly used techniques include instrumental crispness measurement, sensory evaluation, and acoustic analysis. The acoustic analysis method utilizes sound waves to assess crispness. By measuring the acoustic response generated when a food item is bitten or broken, it is possible to analyze the vibrations and their characteristics. The intensity and frequency of these vibrations can provide insights into the crispness of the food. Here is a step-by-step guide on how to perform acoustic analysis for crispness measurement. Step 1. Equipment setup. Ensure you have the necessary equipment for acoustic analysis. This typically includes a microphone, a data acquisition system like Audacity, and software capable of analyzing sound wave data like MATLAB. A method for breaking the food sample is also required. Staple Microsystems TAXT2 Texture Analyzer will be the method used in this experiment for its reproducibility of sample collection. Step 2. Sample preparation. In this experiment, I'll be comparing the crispness between two batches of Lay's classic potato chips. The first batch of chips were fresh out of the bag at a humidity of 17%. The second batch of chips were prepared by leaving them in a 66% humidity chamber for 5 hours. The second batch of chips had a humidity of 45%. I prepared 200 chips for each chip type, each between 2 to 3 inches in diameter. Step 3. Experimental setup. Position the microphone at a fixed distance from the potato chip, ensuring it captures the sound emitted when the chip is broken. Consider using a controlled environment, such as a quiet room, to minimize external noise interference. Step 4. Data collection. Place a potato chip on the device's stand and gently break it, simulating the typical eating process. For this experiment, the ball probe lowers at 1 mm per second for a distance of 3 mm. Simultaneously, record the sound generated using the microphone and data acquisition system. Repeat this process for each chip sample. Step 5. Data analysis. Transfer the recorded sound wave data to the analysis software. The chosen software for this experiment is MATLAB. We will analyze the sound waves to identify key acoustic features associated with crispness. This MATLAB program looks at the sound file and calculates its total sound intensity. The program also counts the number of sound peaks in the audio wave. In previous research, the sound intensity and number of sound peaks positively correlate with perceived crispness measured in sensory tests. The program does these calculations for every chip sample. The mean and standard deviation are calculated and are displayed in this graph. As you can see, the 17% humidity chips have a higher average sound intensity and number of peaks than the 45% humidity chips, indicating a higher level of crispness. This correlates with sensory ratings of crispness of the same samples from a group of trained panelists. We can also analyze the frequency content of the samples. In this MATLAB program, the sound files undergo a Fourier transform to better describe the frequencies present. The files are then compiled into an accumulated frequency plot. In previous research, it has been said that crisp foods are represented by a higher frequency level, with the threshold being 1.7 kHz. Using the accumulated frequency plot, we can measure what percentage of the total sound energy is over 1.7 kHz. The MATLAB program calculated that for the 17% humidity chips, 81.5% of the plot was over the threshold. For the 45% humidity chips, 70.5% of the plot was over the threshold. Therefore, the 17% humidity chips were composed of higher level of frequencies than the 45% humidity chips, indicating a higher level of crispness. In this guide, we went over equipment setup, sample preparation, experimental setup, data collection, and data analysis. By following this guide, you can effectively measure the crispness of potato chips using acoustic analysis methods.